to delete an element from the singly linked list. The basic operations of single linked list, deleting an element can be done either at the beginning or at the end. So, when we are deleting, what are the values that will be updated here? Let us try to see and understand. Now, if I want to delete the first node, that means delete at the beginning, what are the changes I need to do? First, since we are using dynamic memory, we have to free this memory space, and first value has to be updated to 100, that is pointing to the next node. If at all you are deleting an element at the end, last node has to be free, because since it is a dynamic memory allocation, the memory that we are using for the last node has to be free, and the last variable has to be updated with 300, that is last to previous node. So, this is how we have to do, and we have to update the values. Let us see the method delete beginning and delete end, how it can be done. So, here there comes three conditions. The first condition is if list is empty. We already know very well, if the temporary value is null. For example, in the initial condition, the first and last values will be null. If that is there in this case, it means that the list is empty. What if we are having only one element in the singly linked list? So, if you are having only one element, the picturization could be like this. Information will have, consider 3, next is equal to null, and both the first and last variables will be updated with the address of the only node that is having first and last. It means that, observe this condition, temporary of next is equal to null. What is the first? Temporary is equal to first. So, temporary is equal to 100. Then they are checking temporary of next is equal to null. So, temporary value is 100, 100 of next is null. So, if that is the case, only one element is there, and we are deleting the item. So, the item is deleted, statement is printed, free temporary. So, what we are doing? Free 100, that means the memory location 100 will be free, and we are updating the first value to null, last value to null. That means we are bringing to the actual condition where the list is empty. So, the moment first and last values are null, it means that we are deleting the only element that is there in the singly linked list, and it is always mandatory that you need to free the memory. Since dynamic memory allocation is being used, we have to manually, it is the responsibility of the programmer to free the memory. For the singly linked list, if you want to delete the first node, first condition will be temporary is equal to first. So, first we are assigning temporary is equal to first. Temporary is equal to 100. Now, is temporary is equal to null? No. Temporary of next is equal to null. 100 of next is equal to null? No. The condition failed here. It comes to the else part. First is equal to temporary of next. First is equal to temporary of next. That means first value we are updating with temporary of next. So, temporary of next, what does it mean? It means the address 200. So, we are updating the first value with 200. It means directly we are connecting to the second node. What about this memory? We have to free it. So, the moment you call free is equal to temporary, then the memory allocated will be free, and we will have a linked list where the first node address is 200 and it is created like this. Delete at the end. So, delete at the end is also very simple. The first condition will be both the first and last variable will have null values. It means that the list is empty. The list is empty. So, temporary is equal to first. Initially first value is null. Initially first value is null. It means that we are having no elements in the list. Second, what if only have one element? What if you have only one element? If you are having only one element, the condition will be very simple. You have only one node, that has information 3 example, and next field will be null, and both the first and last variable will be pointing to the same memory address location, that is 100, first and last. And what we are doing here, temporary is equal to first value is 100. The moment you are pointing out to the 100, and what we are doing here very simple, free temporary of 100. So temporary is equal to 100, that means we are free this memory 100. After that we are updating first and last value is equal to null. The moment you update the value first and last is equal to null, it means we are going back to the same condition where the list is empty. Let us see, let us take an example of a small singly linked list and delete the last element. How to do? So deleting the last element or deleting a node at the end is little different from delete at the beginning. Let us see what is that. Consider this singly linked list and you want to delete the last node. So where the information is 7 and null value is there. Now to do this, you cannot do it like insert at the beginning, because since we cannot move backward direction in the singly linked list, when you want to delete an element at the end, we have to traverse the whole singly linked list, move to the end and delete the last element. Now what is the first thing? Temporary is equal to first. What is temporary value now? Temporary is equal to 50. Now temporary is equal to 50. The condition if 50 is equal to null, 50 is equal to null, this condition failed. So list is not empty. 50 of next is equal to null. So 50 of next is 100. So this condition also failed. Then it comes to the else part. The moment it comes to the else part, what is written? 500 of next is not equal to last. Temporary of next is not equal to last. In that case, we are keep updating the temporary value. Let us see what is happening over here. So let us number this 1 and 2. So the first point, what is temporary of next? 50 of next is not equal to, what is the last value? 200. So 50 of next value is 100. 100 not equal to 200? Yes. 100 not equal to 200? Yes, the condition successful. So second step will be temporary is equal to 50 next. What is 50 next? 100. So we are updating the value with 100. Since it's a loop, 100 of next not equal to 200. 100 of next. What is 100 of next? 100 of next is 200. 200 not equal to 200. The condition failed. It will come out of the loop. Now temporary is equal to first point. Now temporary, what is the latest temporary value? Temporary value is equal to 100. Now what we are doing here immediately, once you come, the moment you come out of the loop, free last. So 200, we are free this memory, done. That means 200 memory location, we don't have any data now. Next step is temporary of next is equal to null. What is the temporary value now? 100. 100 of next. 100 of next, what is the value that we are having? 200. Now there is no data in the 200 since we free the memory. So the 200 will be allocated with the null value since that is the last node. Since that is the last node, we are updating this to n. Then last is equal to temporary. The last value, what is last value? 200. The 200 memory already we are free. Now this will be updated with 100. That is the previous node to the last node. We are creating a connection. Now a singly linked list where the last node is been deleted and new singly linked list is updated.